Hello everyone, welcome back to my video. My name is Ahmad Alden Aidan with student number 57350, and today I will be presenting about ecological index assessment for aquatic ecosystems. This topic is fundamental because ecological indices help us interpret highly complex environmental data in a way that actually informs management decisions. So, to start, ecological indices are quantitative tools designed to evaluate the condition and functioning of aquatic ecosystems. They translate a large amount of biological, chemical, and physical information into interpretable metrics. This allows us to compare ecosystem conditions across sites and across time, detect degradation early, and guide environmental monitoring programs. In other words, indices turn raw data into something meaningful. And why do these indices matter? Because they let us do four crucial things. The first is provide objective evaluations of ecosystem health, and the second is detect long-term trends and ecological change, and the third is combine multiple parameters into one clear score, and the last is support evidence-based management and policy decisions. And for most importantly, ecological indices reveal ecosystem responses that individual measurements simply cannot capture. So ecological indices fall into several major categories. They there are biological indices, physical chemical indices, trophic test indices, and also habitat or river condition indices. Each category targets a different aspect of ecosystem condition, so the selection depends on what we are trying to assess. And for the purpose is straightforward to objectively assess ecological health, detect stress or disturbance, and support informed management. Without indices, ecological monitoring becomes fragmented and inconsistent. So there is a biological indices. Biological indices evaluate ecosystem condition using organisms that respond to environmental stress over time. Indicator groups include macroinvertebrates, plankton, macrophytes, and fish. Because these organisms integrate environmental changes, biological indices are often more reliable for long-term assessment. For for the first biological indices, there are community diversity indices. The Shannon Winner and Simpson indices measure community diversity and stability. A high Shannon index indicates a complex and stable ecosystem. For the low values suggests dominance by tolerant species, signaling disturbance, and for the Simpson index focuses on dominance. High dominance often reflects ecosystem stress. These indices help us understand how balanced or disrupted a community is. So the next biological indices, there are biotic and plankton-based indices. Biotic indices such as BMWP or the Family Biotic Index use macroinvertebrate tolerance values to evaluate organic pollution. A high BMWP or a low FBI score reflects clean water. And for the plankton-based indices, use phytoplankton composition and cyanobacteria abundance to indicate eutrophication. These are especially useful for detecting nutrient-driven issues. So for the next biological indices, there are fish-based index of biotic integrity or IBI. The fish IBI assesses ecosystem integrity using species richness, trophic structure, and the health of fish populations. Declining IBI values usually indicate habitat degradation, pollution, or altered flow patterns. Fish communities provide a broad reflection of overall ecological conditions. So next is physical chemical indices and WKI. Physical chemical indices focus on water chemistry, and for the water quality index or WKI combines parameters such as dissolved oxygen, pH, turbidity, nutrients, biological oxygen demand, chemical oxygen demand, temperature, and also conductivity. Its strength, its speed, and simplicity. Its limitation is that it only reflects short-term condition and may miss biological responses. So for the next is trophic state index. Evaluates nutrient enrichment using chlorophyll A, surface depth, and total phosphorus. It classifies ecosystem as oligotrophic, mesotrophic, eutrophic, or hyper-eutrophic. This classification helps us identify the severity of nutrient pollution and algal bloom risks. So the next is habitat indices and index selection guidelines. For the habitat indices, such as the Habitat Quality Index or River Habitat Survey, evaluate physical conditions like substrate, flow, riparian vegetation, and bank structure. As for choosing indices for long-term biological condition, use biological indices. For rapid pollution detection, use physical-chemical indices. And for the nutrient issues, use TSI. And for the physical degradation, use habitat indices. And best practice is always to combine multiple indices for a more holistic assessment. So, to conclude, this material, Ecological Index Assessments, offers a powerful integrated approach for evaluating the health of aquatic ecosystems. By combining biological, chemical, and physical indicators, we gain a far more accurate and comprehensive understanding than any single measurement can provide. This integrated approach supports effective monitoring, environment management, and long-term ecosystem protection. So that's all from me. Thank you for watching this video and see you in the next video. Bye.